Good day, the viewers and all the learners at home. You're highly welcome this morning to our class. The number basis continues today, and this will be the third contact on number basis. But today we're going to look at how to convert numbers given in base 10 to any other basis. So the topic says converting numbers from base 10, which is ternary, to other bases. You can convert to base 2, you can convert to base 4, you can convert to base 6, but you start from base 10. From there you start moving to other bases. How do we do that? The process. Please take note of this because this is the basic skill. The process is by long division and taking notes of the remainders. The answer is by writing the remainder from the last to the first. In which form? Upward. Upward. As you are dividing, you are taking note of the remainders. So, when we now finish, the answer is by writing the remainders from the last to the first. Because you may get 3 remainders, 4 remainders, depending on the size of the figure that you are given. And when you have to write the answer, don't forget, you don't start from up, you start from the last, at the bottom of the remainders, and align it upward. And you have converted to the expected base. Now let's take a look at the first example. Convert 47 base 10, which is ternary, to base 2. And base 2 is also called binary. How do we do this? Procedure. 47. Then we rule. Now from here we now start the work. First, we have to take it to base 2, so we divide by 2. How many 2 in 4? 2. No remainder. 2 in 7? 3. 2 times 3 is 6. There's 6 from 7, you have 1. So remainder 1. We continue with 2. 2 in 2, 1. 2 in 3, 1. Remainder 1. Continue with 2. 2 in 11, 5. Remainder 1. 2 in 5. We have 2 and remainder 1. Now 2 in 2. We have 1. Remainder 0. We continue until it becomes 0. 2 in 1, 0. Not possible. Remainder 1. Now from here we now generate our answer. That is from the bottom to the top. So we start with this one, which is 1, followed by 0, followed by 1, 1, 1. Then 1. Now to base 2. And this is our final answer. Therefore, 47 in decimal or base 10 to be converted to binary, which is base 2, will give us this as our answer. And therefore, we have 101,101 to base 2. And this is our final answer. Now, let's take a look quickly at the second example. The second example says convert 854 base 10 to base 6. Same thing we did in the first example, we do here too. Now take a look at this. Your exercise books are ruled, so the subsequent one you might not need to rule. 800 154. It's in base 10. We are taking it to base 6, so we divide by 6. 6 in 8. 1. 1 times 6, 6. Take 6 from 8, remaining 2. Bring the 2 here. 2 in front of 5 equals 25. How many 6 are there in 25? 4. 4 times 6, 24. Take 24 from 25, you have 1 left. Bring the 1 here, it becomes 14. How many 6 are there in 14? 2. 2 times 6, 12. Take 12 from 14, you have remainder 2. You continue with your 6. 6 in 1, not possible in 14, we have 2. 2 times 6, 12. Take 12 from 14, you are left with 2. Bring the 2 here, this becomes 22. 6 in 22, that is 4. Now 3. 3 times 6, 18. Take 18 from 22. You are left with 4, remainder 4. Continue with your 6. 6 here, how many times? 3. 3 times 6, 18. Take 18 from 23. You have 5 as your remainder. Continue with 6. 6 here, 0. Remainder, 3. And once this becomes 0, you have come to the end of the word. The next thing is to align the remainder upward. That is, from the last to the first. And how do you do that? First number, 3. So you now say 8. 154 base 10 is equal to 3. This is the first number, followed by 5, followed by 4, followed by 2. Now which base is this? Base 6. That's the end of converting numbers in base 10, which is denary, to any other base, base 2, base 3, base 4, base 5, base 9, anyone you are given. This is the procedure. Please kindly watch this over and over and use it in solving the questions. They are very simple. Just follow the procedure. With this, we've come to the end of today's class.